This video explains pressure definition, pressure head, errors, and the method to rectify it. Hello and welcome to Answering ATPL. The focus of this channel is to provide solution for ESA, ATPL question and other aviation related stuff. Let me know in the comment section below if you are currently taking ATPL theoretical examination. If this is your first time here, consider subscribing to my channel and click on the bell icon to get notified when I publish new video. Definition: any object that is in the Earth's atmosphere is subjected to atmospheric pressure due to the surrounding air. This pressure is also known as static pressure. This pressure always acts onto objects, including aircraft. Static pressure is defined as the pressure of a fluid on a body when the body is at rest relative to it. Once the object is moving, the forward-facing side of the object will experience additional pressure due to the force of the air that has been brought to rest against the body. This additional pressure is known as dynamic pressure. Dynamic pressure can also be exerted onto a stationary object when the wind blew toward the object. Dynamic pressure is defined as the increase in a moving fluid's pressure over its static value due to the motion. The combination of these two pressures is known as total pressure or pitot pressure. In equation, total pressure equal to static pressure plus dynamic pressure. Pitot tube. Pitot tube or pitot probe, which is marked by the red circle, sends the total pressure. The tube is fitted to the airframe with its opening facing directly into the airflow. The tube is placed outside the aircraft boundary layer to ensure minimal disturbance to the airflow. For propeller aircraft, the tube will be placed in an area that is clear from the propeller wash. These probes are typically mounted close to the nose at the wingtip on a pylon extending well below the wing or at the top of the fin. The tube is fixed parallel to aircraft longitudinal axis to ensure full dynamic pressure is sent. The air can either be brought to rest inside the pitot tube against the stagnation wall, which is merely a pressure sensing flat surface, and then transmitted up the pitot pipeline to the user instrument, or pass directly up the pitot pipeline. A pinhole drain allows any moisture to leak away to the atmosphere without significantly affecting the sense pressure. The probe is also equipped with a heater which is powered from the aircraft electrical supply and switched on as required by the flight deck crew to prevent the formation of ice. Static source. The ambient pressure or static pressure is measured using a static source or static vent. The static source sends the static pressure of the atmosphere, which is undisturbed by the airflow. The source or vent is positioned on the aircraft where the airflow is undisturbed by its passage, and with its entrance perpendicular to the airflow. The vent is designed not to disturb the airflow passing through. Vent pipe connections are installed with a slight downward angle to ensure adequate drainage. It is essential that the vent plates are not painted, as this would impair their thermal efficiency, and a do not paint placard is often placed next to the static vent. The direction of the airflow around the static vent may vary as the airspeed and configuration of the aircraft changes and may induce errors known as position error or pressure error. Minimization of this error is achieved by carefully positioning the static vent or by using multiple vents to average out the errors. This is known as static balancing, and it is obtained by fitting vents on either side of the aircraft fuselage. The purpose is to even out any differences of pressure that are caused by the sideways motion of the static vent, which occur during a yaw or side slip condition. If a failure of the primary pitot or static pressure source should occur, introduction of error may occur in the instrument readings. The installation of a standby system in some aircraft acts as a safeguard against partial failure. whereby static pressure or pitot pressure from alternate source is usually selected and connected into the primary system. A blockage of pitot source only affects the airspeed indicator. An obstruction of the static source affects all the instruments, and it is thus common practice to provide an alternate static supply. Internal alternate static source. The internal alternate static source is only available for unpressurized aircraft. The changeover to an alternative static source is usually achieved by selector valves located in the static line, which are located on the flight deck within easy reach of the flight crew. The position of alternate static port considers the possible disturbance in the cabin such as window, ventilation vent, and doors. External alternate static source. Moderate or large aircraft usually have a minimum of 2 separate static systems and a pair of balanced static vents. The second pair of static vents is typically referred to as the auxiliary or standby static ports. On the screen is the typical layout of the system. Combined pitot static or pressure head. On some aircraft, combined pitot static head is used. The combined head is usually mounted on a pylon below the wing toward the tip, thus reducing the position error to an acceptable level, although accuracy is well below the standard achieved by systems that are more sophisticated. A typical combined pressure head system is shown on the screen. Errors. Now we will look onto errors associated with air pressure measurement. The first one is position error, or also known as pressure error. The ideal airflow of pressure head system should look like the animation on the screen. However, due to speed of the aircraft, the air surrounding the pressure head becoming turbulent. As the speed increase, the turbulence also increase. This turbulence gives rise to inaccuracy in both static and total pressure. The amount of inaccuracy depends on the location of pressure head and speed of the aircraft. The turbulence will cause static pressure to underread due to suction effect and cause pitot pressure to overread or underread depending on its position. At high angle of attack, partial total pressure might be sent by static head, which will cause overread of static pressure. The amount of total pressure sent will decrease at high angle of attack. Error will be greatest at high angle of attack and low speed. Changing in aircraft configuration like deploying flap, slat or landing gear will also have effect on pressure head system reading. Deployment of this service will change the angle of attack, thus increasing turbulence around pressure head system. Position error are determined during aircraft flight test and tabulated in the flight manual. The usage of static vent instead of pressure head can significantly reduce position error on static pressure reading. The second error is maneuver-induced error. This error is the result of dynamic change that produce short-term variation of pressure at static vent. This error is most apparent during changes in the aircraft angle of attack. It will cause lag in the aircraft pressure instrument reading. For example, if you are leveling off from a climb, the vertical speed indicator as shown on the screen will take some time to reduce to zero. The higher the altitude, the time taken for vertical speed indicator to return to zero will be longer. If you want to learn more about ATPL or aviation, start now by hitting the round subscribe icon. Also, if you have any question or comments about any ATPL or aviation related problem, you can leave them in the comment section. Thank you so much for watching. I'll see you next time.